All right. Doesn't look like we have many more people coming, so we'll get started. All right. Welcome. This is Python and Spreadsheets, Earth Dog Edition. This here is Kojo Idrissa. Sorry. He's a former accountant, now developer, and a DjangoCon organizer. Please welcome Kojo.
Thank you. I'm having trouble with my mic cord here. That's kind of sad. So as was pointed out, and as I just mentioned, I used to be an accountant, now I'm a developer. There's a bunch of things I do here. I am the North American ambassador for the Django Events Foundation North America, so hello from North America. This is my first time in Australia. Interestingly, when I was a university instructor at one point, I actually taught for the University of South Queensland, but in their China campus in Guangzhou, so I've never been to Toowoomba, but I've got some familiarity with Australia. So let me just sort of jump right into it. If you're curious about the whole Year of the Dog edition, you can reach out to me on Twitter. I can explain that later. But now I'm going to jump into the exciting world of spreadsheets, because that's what the people want. That's what the people crave, the spreadsheets. So I'm going to start off by describing the problem here, and then I'm going to summarize a solution that I built using OpenPyXL. OpenPyXL is a library that lets you work directly with XLSX files, or the current Excel format of files. And then I'm going to look at some of the opportunities that a library like this presents you, but also some of the problems you might run into in trying to work with spreadsheets programmatically. Sometimes there's some issues. So the code that I'll be showing is going to be usually fairly simple code. I've done a lot of different versions of this talk. Some versions have been more tutorial-based for new programmers, but the code is going to be relatively simple. I'm going to be skipping over some of the more like this sort of the standard Python stuff. Instead, I'm going to be focusing on the new bits that you will get exposed to by using OpenPyXL. There's some new data types that you'll get exposed to. So whether you are someone completely new to programming or a longtime veteran of Python, you probably haven't worked with these particular data types before because they're new to OpenPyXL, but they are useful for working with spreadsheets. And also, when you're doing this kind of thing, the really interesting code is going to be based on whatever your specific use case is. I did a quick informal poll of the audience. A little more than half of the audience seems to be people who work with spreadsheets, but not in a financial capacity. So how do we start? We're going to start with, as always, starting with your data. So here we have a spreadsheet, a screenshot of a spreadsheet, because jumping back and forth between slides and spreadsheets makes for a terrible presentation. I've learned that over time the hard way. So we've got a screenshot of a spreadsheet here, and this is timesheet data. And so this is data, sort of simulated data from a company. And in a lot of companies, a lot of professional service firms, like accounting firms, engineering firms, they want to keep detailed track of their employees' time, how much time they spend working on different projects, and that sort of thing. So that's what we've got here. So here on your left, you've got employee number, which identifies the employee, then a cost center, which is a small group within the company, a division, which is a larger group within the company, who that employee's manager is, what date they worked, the employee's name, and then the hours that they worked. And so if you take a look here, you'll notice the first two rows, it's the same employee, just their time worked on different dates. And then the remaining rows in this screenshot of the example are another employee, but it's time worked on different dates. So what we want to do here is we want to take this data and we want to aggregate it so that we have the total number of hours worked for one employee instead of just this broken out thing. But again, most timesheet systems are going to give you this broken out detail. So now begin to do some namespace confusion and some of the new data types I talked about before. People often talk about spreadsheets and just sort of say, oh, a spreadsheet, give me the spreadsheet, and then look at the other spreadsheet. And I know I need the spreadsheet that's inside the spreadsheet, not the first spreadsheet, but the second spreadsheet. There's a lot of confusion. So here we're going to be a little more specific, partially because it's helpful, but also because OpenPyXL requires it. When you have an XLSX file, that's known as a workbook. And then so that's the file you can pass around to other people. Each workbook is then made up of worksheets. And so if you open a spreadsheet, the individual tabs you see inside, those are each worksheets. Each worksheet is made up of cells. And so I'm pointing that out to you not to be pedantic, but because each of those is going to be a different data type in OpenPyXL, and each of those different data types, each of those different objects is going to have a different set of attributes that let you work with that data type that are relevant to it. And we'll see more of those as we go forward. I'm going to cover some of the basic, most initially useful attributes for each of these data types, but there are so many more that I'm just not going to have time to cover. And so if you find the documentation for OpenPyXL on Read the Docs, it will cover all of that in exhaustive detail, and there's a lot of stuff that's going to be really helpful. So the first thing you're going to start with, I'm going to start with an example where you're getting a spreadsheet and you want to get the data out of that spreadsheet. So the first thing you have to do, of course, import OpenPyXL, and then you're going to create this workbook object in memory. So this demo workbook, you're using the load workbook method, which, again, well named. You have to give it the name of the workbook file that you're using. And then this second argument I have, this data only equals true. It's not required, but what it does is, if you have a formula in your worksheet or formulas throughout your workbook, this will return not the formula itself, but it will return the results of the computation of that formula. And so that's helpful. So you just, because that's, in most cases, that's what you want. You want the actual data itself. You don't want the formula. And so now we have this workbook object in memory, but you need to be able to work with a specific worksheet within that workbook. And so we create this demo worksheet object, and again, a well-named function, get sheet by name. You pass it the name of the sheet, the worksheet within the workbook that you want to work. Here it's a worksheet called clean data. And so now you have a workbook and your worksheet, and you're really going to be working with the worksheet mostly going forward, this specific worksheet. And so we saw from that prior employee example, if we wanted to aggregate that employee timesheet data, well, first we need to know, okay, well, who are employees? Because there's a certain amount of repetition in the employee ID numbers. And so we're going to create a set here so that we have a unique grouping of employee IDs. And now this is where we start to get into some of the specifics of the different data types. So I've created this employee ID set, and then I'm saying here for row in demo worksheet.rows, again, remembering the demo worksheet is this new worksheet data type that is new. The .rows attribute, what it's going to do is it's going to return a generator object. And that generator object is going to give you a tuple of cells, the cells being, again, a new data type. And so each tuple of cells represents one row in your spreadsheet. And so what I'm saying here is, so for every row in that worksheet, I want to know that if the row 0 value is not equal to employee number, then add that value to my employee ID set. So this row index 0, that is going to be a particular cell. So again, this new data type. That cell data type has the .value attribute, and that's just the simple way to get that value out of that cell. So you've got a workbook, then a worksheet, and then the cell. Pull the value out of the cell, do what you want with it. And so here, this is me pulling those values out. That second from the bottom line is me it's a simple way to skip over the header row. And so now I'm pulling those employee numbers out and I'm putting them into a set. And now I want to aggregate all that data. And so I've created this employee aggregate dictionary. I've decided, okay, I want this information about the employees in a dictionary where I want to use the employee IDs as the key for the dictionary. And then I'll say, okay, for every employee that's in that, that ID set I've created, then I've got this list comprehension here where I'm going to the index 6 in a row. So I'm going through each row again. And you see in the second line from the bottom that for row in demo worksheet.rows, again, the generator object is giving me a tuple of cells that represents each row. So for row index 6 here, the 6th cell in that thing, which was the one on the far right, which is where the hours are, I want that value. And so I'm just adding the value from each row if the index 0 in that row, if the employee number is the one that I'm looking at. So I'm going through and just pulling those hours out. So that's going to give me a list of hours for each employee. And then I'm going to do the same thing for the other employee attributes, the cost center for that employee, the division, and the manager. Although in those cases, there should only be one of those. So what I end up with is this situation where I build up that employee aggregate dictionary. And so I'm using the employee ID as the key, and then I'm assigning the hours, the cost center, the division, and the manager. You see there in the hours attribute, I'm summing up that list of hours that I pulled out in the last frame. And so at this point, you're basically done with this input process. You have a spreadsheet. You've taken the data out of the spreadsheet that you wanted, and then you've done a simple transformation on it where instead of a bunch of individual hours, you aggregated those hours. So now what you have is a list, a dictionary where each key is an employee, and then you have the total numbers of hours that employee worked in the month, who their manager is, what cost center they're in, and what division they work for. And so at this point, you're sort of done with the specific OpenPyXL part, depending on what you want to do. So you pulled your data out of the spreadsheet. You can now just pass this on to do whatever. You can turn it into JSON, pass it to someone else. You can do other transformations on it. So that's sort of the end of getting data input. So the question then is, what about if you want to do data output, or if you want to do some other things? But before we get into that, I'm going to point out one other change. So here, you notice here, this, I've been using this row index.value to pull data out of specific cells. There's another way to do that instead of just grabbing it, say, from a row. You can also get the data from a specific cell in a sheet. So here, we got the demo worksheet, and then I'm using the actual cell name. So in a spreadsheet, you've got letters across the top, numbers going down the side. And so if I can say I want cell A1 or cell B7. And so this approach will let me get the value from a specific cell. And I'm using this as an example just to build a header. So if I just wanted to build a header row that I want to write out later, I can just grab A1, B1, C1, D1, and grab those specific values and build a header that way. But I have this here just to sort of point out that this is another option. You can grab the values from specific cells. You don't have to do it row by row. All right, so let's say you have another process where you've got code that's already running, but you want the result of that code to be written to a spreadsheet so you can give it to someone else. In the last example, someone gave you a spreadsheet and you need that data. Here, you've already got data, but you need to put it into a spreadsheet to give to someone. So how do you go about that? First, again, we go back to those data types. You create a workbook for output. So this OpenPyXL.workbook gives you this output book. But then you need to tell it what sheet you're going to want to work with. And so here, you can create your own sheet. And then you can give it a name. Here, I've given it the name aggregate time. The last argument here is a 0. That's optional. That's the index for where it goes, where that sheet will go in the workbook. By default, it will go to the end, but giving it the 0 index means that it will go to the front. And so you can do some ordering that way. So create your workbook in memory, create your worksheet in memory. And now, I'm going to create this output data object here, which is going to end up being a list of lists, a nested list. So each internal list is going to represent one row in the spreadsheet that I'm writing out. And so the first list that I append to it is that header list that I just created a little while ago. And then we take the employee aggregate dictionary that we built a little while ago, and we're going to write out these new rows, and we're just going to write in the employee number, the cost center, the division, the manager, and the hours, write that out to the new row, and then append that new row to the output data. And so we're just going to build up this output data nested list for to be the structure that we can use to write out our data to the workbook. And so now, here is where things get a little bit tricky. So we've got this structure where, again, nested list, each internal list represents one row in the spreadsheet, and now we want to write this to the worksheet. So it gets a little tricky because if we look at this, you'll have, and I know this just from being familiar with the example, you're going to have 49 employees, and you have 5 different columns, 5 different types of data about them: their employee number, their cost center, division, their manager, and their hours. So 49 rows, 5 columns. Python will count those from 0 to 48 for the rows and 0 to 4 for the columns. But spreadsheets start counting at 1. And so if we look at the second line from the bottom here, you see that that's kind of what's going on here. So we've got output sheet, which is that worksheet object that we created in memory. And then here, .cell. And we're using the .cell method because I want to write to a specific cell in the output sheet. The question then is what cell? You can give it the row number and the cell and the column number, but if we use Python to create those, it's going to start off with row 0, column 0, and spreadsheets can't deal with that. So I'm having to do a little bit of trickery here, adding a 1 to each one. So it will count from 1 to 49 for rows instead of 0 to 48, and the same with columns. So we've got these nested for loops. Some people will tell you a nested for loop isn't the best way to do things. It varies. That's a computer science issue for another time. And so I'm just going through row by row through the output data, and I am going through each row, then in each row, going through each column, and then writing the value from each of those cells from each of those positions in that internal list into the cells in the workbook. I'm sorry, in the worksheet. That's why it's important to be pedantic about that. And so at the end of this, I'm going to have the data from that output data object that I created from that set of nested lists. That's now going to be written into my output sheet object that's in memory now. And so now I have that output sheet object that's fully populated. Now we come to the most important line of code in this particular example. Output book.save. So you don't have an actual spreadsheet until you've done this. And I point this out, I mean, it deserves its own slide. It might seem a little obvious, but you can do all the fancy processing and blah, blah, blah you want. If you don't do this, you don't have a spreadsheet to actually send to anyone. So I thought this was important enough to warrant its own slide. You give it a file name, and there you go. So we've seen basic input and basic output. What if you want to do something that's a little more complicated? So this example comes from something I did in my final accounting job, where there was a lot of manual copying and pasting. I had a situation where you have these different cost centers that people are grouped in, but each of those cost centers is associated with a different function in the business. So maybe the accounting function, the engineering function, the marketing function. So you've got the different cost centers that are associated with those. So they wanted this sort of employee time data, but they wanted it broken out by these functional groups, but also only the cost centers that were associated with that particular functional group. The issue there was that the way it was being done before was that it was a manual copy and paste method. So you'd filter it for one cost center, copy it, paste it, and then filter for the next one, da, 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 da. And that was a manual process that took between 6 and 8 hours, depending. Also, a lot of these things that you were sorting on, the cost centers and the employees were very fluid. So in any company, people come and go, so you've got a different number of employees. These different functional groups, there were between 10 and 15 of them. And then the way that the different cost centers, there were about 80, but the way they were mapped to the different functional groups might change from month to month. And so that might change from month to month, and then this was a monthly report. You also might have people who would come and go. So the question is, how do you deal with this sort of chaos? Here, JSON was the answer. And this is not particularly an OpenPyXL or a Python thing, but that mapping of the cost centers to the different functional groups didn't exist anywhere. It was just a matter of looking at last month's report and then asking people what had changed. And so by doing this, by having this JSON mapping, you can take this, read this in, and then use that create worksheet function, give that worksheet, a specific tab, the name, which is the key here of one of those functional areas. And then when you're creating that output data object that we saw earlier, have the output data object only pull data where the cost center matches one of the cost centers that's mapped to the particular functional area you're looking at. And so this makes it easier for you to just make changes to this one JSON file and then let the code run through and do that processing for you. And it speeds things up quite a bit. And this is sort of this is a brief example of what that looks like when it's done. So you'd have an accounting tab, and then you'd have the cost center sorted by cost center and then sorted by employee name. So this is a brief example of what that looks like when it's done. So I've gone through some examples, and again, I asked the audience before how many of you work with spreadsheets in a financial capacity or in a non-financial capacity. And I asked that question, and I point this out because, again, my experience is having been a former accountant. But even then, I wasn't really working. In this example, I wasn't working with financial data. It was timesheet data. But you've got these three sort of general use cases where OpenPyXL can be really helpful for you. The first is a single-ended input where you are given a spreadsheet as input, and that's your data source. And then you just have to get the data out of it and then do whatever you need to do with it, and then you're done with spreadsheets. Traditionally, people have used CSV files for this. There are some advantages to using this method as opposed to a CSV file, which I'll get into in a second. The other approach is a single-ended output situation, where you already have some sort of process that's running, but you need the results of that, for whatever reason, to be in the form of a spreadsheet, often because someone needs to see it in a spreadsheet. And often, I'll talk about this a little later, that's often sort of where you end up. You end up with spreadsheets because someone somewhere wants a spreadsheet. Someone's boss's boss requires a spreadsheet. So you've run into this, I see. But that's just sort of the reality. Spreadsheets are sort of everywhere, and you can't get around them. And so those are often the situations you end up with. Either someone's giving you a spreadsheet because that's what they've got. Honestly, the real reason for that is a majority of business applications are really just relational databases with a point-and-click front end. And so the output they give you is a relational table that looks like a spreadsheet. So that's kind of the why. But these are fairly common situations. Either someone's giving you a spreadsheet or someone requires a spreadsheet from you. But then another general use case is this sort of double-ended thing where you are given a spreadsheet, and then you then have to produce a spreadsheet. And so that's what had to happen in this example. I was, a spreadsheet that was generated from a business application that just dumped out a database table, then needed to be turned into another spreadsheet because someone else needed to see a spreadsheet. And so, but these are sort of the general use cases where OpenPyXL can help you and be of use to you. And again, I point those out because depending on what your use case is, whether you're using financial data or some other sort of data, you might find yourself in one of these situations. So what am I not talking about? Again, I pointed out there are a lot of different attributes for each of these new data types. There's a workbook, worksheet, and cell data types. So there's a lot of things that I just don't have time to go into. One of them is this issue of styles. And there's a lot of style information that you can read from cells. This is going to be one of the primary benefits of using this as opposed to just turning a worksheet into a CSV, or turning a spreadsheet into a CSV file. All that metadata gets lost. And so you can both read from and write to the style information from cells. So you can look at the fonts, what type of font is it, what size, what color. And I know in a lot of financial applications, sometimes things will change color based on their value. A loss of income might be shown as red, whereas positive income might be shown as black, or what have you. That might vary from application to application. You can tell what sort of color, fill color the cell has. You can tell if a cell has borders. But again, you can also write that data. So if you're needing to create a spreadsheet, often that spreadsheet needs to look a certain way. And so you can automate that process by saying, OK, once I'm done with all this processing, write this stuff to these cells, but then make these cells one color, make those cells another color, give these cells a border of a certain type, and so on and so forth. So there's a lot of formatting that you can do. I just don't have time to show all of that. I'm also not talking about charts. And so one thing that you can do is you've got your data, and again, you might see this in a more of a single-ended output situation. You have data, some process is creating data. Someone wants to see a chart or a graph of it. Well, everyone isn't going to run matplotlib or what have you. So you can then create a chart, use your current process, create a chart, spit that chart out to a spreadsheet, and then pass that spreadsheet around to people. Because again, in a lot of business situations, many people have Excel installed on their machines. That's one of the reasons spreadsheets get used so often. So there's a lot of things you can do with charts. And so now we come to sort of the good news, bad news. The bad news being, again, there are lots of details that I haven't shown you that I don't have time to show you. The good news there is it is because this project is under very active development, and so there are new things that are being added to it all the time. Just sort of as an aside, when I started using this library in 2013, when you read in rows, that worksheet.rows, it didn't give you a generated object. It just gave you a tuple of tuples, and which in general, maybe not a bad thing, but I was working with spreadsheets that had between 15 and 20,000 rows of data. And so as your data gets larger, your memory gets eaten up fairly quickly. So the library has changed a lot over time. But again, the good news is it's under active development. And so the odds of you being left hanging are fairly low. So here with this slide, and I said this to someone earlier, and I've said it on more than one occasion, there are no bad spreadsheets. There are only bad people who use spreadsheets. And so one of the things that will create a problem for you, again, if the only spreadsheets you get are this sort of structured data like the ones I've showed in this example, everything will be fine. The reality is that probably won't be what you always get. You'll probably get something that was made to look pretty. So unfortunately, spreadsheets are now often used as a visual medium. Again, often because someone's boss's boss wants to see it look that way. And so this sort of visually structured data can be hard to parse programmatically. Now, the fact that you can, again, read from and write to specific cells, like I showed a little earlier, that makes it a little bit easier. But those solutions tend to be a little brittle. But that's, as a programmer, that's going to be a point of frustration. But again, you can work around that in certain ways. But again, this ability to read from and write to specific cells and the ability to read certain styles and write certain styles back can help you deal with that. But just this general unstructured data and also the visual output requirements. Those are going to be sort of frustrating things for you as a developer working with spreadsheet files. It's not all going to be simple structured data. Now, the good news from that is this is an opportunity to make new friends. So how do you do this? on the one hand, you can help some of your coworkers automate some of their processes. I'd say step one, start with you. Automate your own processes. Make your own life easier. But then you can help other coworkers, people around you, automate their processes. And when you start doing that, I'm gonna make some suggestions here as the North American ambassador. I'm here to help Australia because NORAM cares. We love our cousins here in Australia. So I'd say start with people that you don't mind doing a little bit of extra free work for, people who are close to you. As you would say in Australia, start with your mates. Don't start with just random people. And also people who will appreciate the fact that you're actually trying to make their lives easier. They'll appreciate the extra work. But also, maybe as a developer, if you've got coworkers who have asked you to teach them how to code, this is a good starting point. It's like, oh, well, if you wanted to learn how to program, I see you do a lot of stuff with spreadsheets. I can show you some basic things that will make that process easier for you. So this is a way for you to make new friends. Also, when you are dealing with the issue of a spreadsheet needs to look a certain way, you might be able to convince people to change that and to sort of standardize their data a little bit if it can greatly reduce the amount of time it takes to generate the things they need to generate. And that last example, the example that sort of prompted this talk, we were spending like between 6 to 8 hours every month doing manual copying and pasting. I wrote 2 chunks of code that turned most of that into about 90 seconds. And so people might be willing to change the way things look. It's like, oh, well, wait a minute. Instead of this taking a day, I get a day back. So that's something to consider. And again, the fact that you've got the style attributes, that can help you work with some of these visual things, because some people might just be adamant, well, no, my boss has to see it this way. Well, you can provide some of that. You can recreate some of that. So that is a thing that is possible. So that is all that I've got for now. I've got a little bit of time for questions and answers, just a second. But if you don't have a chance to ask a question here in the next few minutes, I am Transition on Twitter. My website, my blog is not terribly updated, but that's just kind of a thing. Sorry about that. But the code will be available. It's not available right now, but it will be available on my GitHub. I am also 195 centimeters tall and pretty easy to see, so I'll be here through Tuesday if you have questions after this. So, thank you.
All right, we've already got a question or
There's
two.
a question up it's him? Oh, sorry.
Hi. Nice talk, by the way.
Thank you.
I read in the documentation for the OpenPyXL, it says read and write Excel 2010. Do you know if there are workarounds to, like, if you have, like, your people have, like, you are using 2016 and some are using older versions as well. Is there a way to, like, load those files or manipulate or create those?
So I believe this will work with and the big distinction here is between the XLSX format and the XLS format, which is the older format. I honestly can't recall. So I started using this because then there's another set of libraries called XLRD and XLWT, which will work with those older formats. In my case, I needed the newer format, and so I started working with this. But I think this will also work with those formats, with the older formats. I honestly can't recall. But the simple thing is if you've got a newer version of Excel, just turn that XLS into an XLSX file. The newer versions of Excel will do that conversion for you. So.
Hi, just wondering if it's possible to explore a file using Python if you don't know the structure. You talked about examples where you know the structure of the file.
It is possible. I don't know that I would recommend it. So one of the things that Excel excels at, there's a table I'm trying to phrase, is being able to show you the data. So I would recommend just opening it up first if you can. But then if, for instance, the file is too large and you simply can't do that, then you could just do this, open the, so let's see. You can open a workbook. If you know the name of the file, open a workbook. And then, I didn't show this, but there's that load worksheet. But you can also get the names of all the worksheets. And then you can go through and then just have it, do that rows thing for every worksheet and then just see all the data that way. So that's sort of ugly. But it would be easier if you could just open it in Excel. Okay, one question, and I know you two had questions. I'll make sure I'll get to you all if we can't do it here. Okay. Question?
I do have a question. Oh, sorry. Yeah, there are a number of Excel libraries. If you look through PyPy, there's heaps of them. I just wonder why you
Why this one?
Why this one? Yeah.
I think the big reason was, again, so this started like in 2013. So in 2013, XLRD and XLWT was maybe the most commonly used one, but then they wouldn't work with the newer file format, and so this one would. So I sort of stuck with this one, but there's also been a lot of movement in this space where some projects have merged with each other and that sort of thing. So.
So in my work, I found that pandas is often really useful for dealing with the kind of spreadsheet data or importing spreadsheets, but there are certain things that it can't do. Do you know if there are good ways to make them work together, make OpenXL work with pandas?
Off the top of my head, I'm not, because I haven't done much work with pandas, but I know that if you look at the OpenPyXL documentation, they have a section called Working with Pandas in NumPy. So they've done that for you. Yeah. So I know it's possible. I know it can be done. I couldn't tell you how, but I know the documentation can.
In one of my previous jobs, I had to deal with spreadsheets that were full of floating point numbers. Trouble is, the person who was typing it in sometimes used O instead of 0.
Oh.
So
that's problematic.
my question is, do you just hand back the spreadsheet to the person and say, no, do it again? Or do you automatically try to alter the data?
So that's going to be an organizational question, honestly. So it's sort of like this issue I had with the JSON, the question of what do you do when people are putting in bad data? OpenPyXL can't really help you there. That's sort of a how well do you know your coworker and how is your organization structured type of question. And also with the frequency of the issue. So.
Hi. I'm sorry. Yeah.
No, go ahead.
Hi. I recently got a request from a colleague that when I'm creating the Excel file, if it's possible to add some macros as well using the Python code. Have you got any suggestions on that?
Let's see. Adding new macros with Python code, that I'm not sure of. I know, let's see, there have been a lot of changes in this space. So I don't know if you can actually use OpenPyXL to put new macros into a spreadsheet. I know it will work with those XLSM files that have macros in them, but as far as the ability to write new macros, off the top of my head, I don't know, but that's an interesting question. If you find out, let me know. But
I'm searching for it, so I'm just asking if you dealt with that before.
There's a
We have
question.
time for one more.
My question is sort of answered. So with pandas, what sort of experience have you had with that? Just
really very little. And so, and part of the reason is when I started this particular project, my options were either sort of looking at pandas or use this. And so I was at the time at the beginning of my programming journey, and I wanted to focus more on learning sort of core Python as opposed to learning this larger pandas library. So and that's also another reason that I chose this library as opposed to pandas or something else.
All right. So with that, we'd like to thank Kojo for his wonderful talk.
Thank you.